question 8.2, and we're going to do some arithmetic with matrices. All right, so the first thing that we need to know about matrices as we're starting to talk about arithmetic is the way that we normally write matrices is with an uppercase letter. So we would say matrix A, matrix B. So uppercase letter usually is going to be the way we write a matrix. The other way you'll see it is, the other way we could write matrix A is in brackets, lowercase a ij, and that just means the matrix filled with my components of A. The other way we would write B is a lowercase b ij. So this is how we're going to write, how you'll see matrices written. Matrices are equal. Matrices are equal only if they have the same size. So they have to have the same size. They have to have the same order. Because it doesn't make sense to say a 2x3 matrix is equal to a 4x6 matrix. They have to be the same order. Only if they're the same order and every corresponding element is equal. So you have two matrices, they're exactly the same size, and the exact same numbers are in the exact same place in both matrices. So that's the only way that we have matrices being equal. So that's a pretty easy idea. Adding matrices. To add two matrices, again, they have to have the same order. So we can add a 2x2 matrix to another 2x2 matrix. Doesn't make sense to add a 2x2 matrix to a 3x7 matrix. They have to have the same order. And then we just add the corresponding elements. So adding matrices is really an easy idea. We're just adding a bunch of numbers. So if we have, for example, we'll do a quick example of adding matrices. So our matrices here are the same size. We have 3 rows, 2 columns, so each one is 3x2. We're just going to add the corresponding elements. 4 and 8 is 12, negative 5 and 9 is 4, negative 6 and 6 is 0, 2 and negative 1 is 1, 3 and 3 is 6, 8 and negative 2 is 6. So we just add the corresponding elements. So that's a pretty easy idea. Adding matrices by hand is generally going to be way faster than even entering them into your calculator. So any questions on equal matrices and adding matrices? All right, the next operation is multiplication, or what we call scalar multiplication. And what this means is just multiplying a matrix by a number. So if C is some number, and we're multiplying C times A, what we do when we multiply a matrix by a real number is just multiply every element by C. So again, another really easy idea, really easy operation. We just multiply every element by C. If we are talking about the negative of a matrix, negative A, all we're doing is multiplying our matrix by -1. So we just multiply every element by -1. So the negative of a matrix is just we multiply every element in the matrix by -1. We change the sign on every element. So these two ideas are pretty easy. When we multiply by a number, we just multiply every element by a number. When we're talking about the negative, we just multiply every element by -1. So any questions on that? So this is pretty easy idea. I'm not going to do any examples of this. We're just multiplying everything by a number. All right, the zero matrix. The zero matrix is just the matrix with every element 0. And we use a capital 0. The other way you'll see it written is the matrix with all zeros. It just means that every element is 0. And one thing to be careful of, I know it seems like a minor distinction, but it really makes a difference. The zero matrix does not equal the number 0. Zero matrix is a matrix of zeros, where the number 0 is just 1, 0. So now that we know a little bit about adding, scalar multiplication in the zero matrix, we can talk about some of the properties of matrix arithmetic. So any matrix plus the zero matrix equals a zero matrix plus any matrix. It's just the matrix itself. I can change the order of addition for matrices. Doesn't matter what order I add them in. We also have the associative property. I can group them however I want. If I multiply by two scalars, that's the same as multiplying by a scalar, multiplying the scalar in any order. So basically I can multiply the scalars in any order, is what this is telling me. 1 times A just gives me A back, just like we'd expect. If I multiply a sum by a scalar, I can distribute. And if I add two scalars and multiply by a matrix, I can distribute the matrix. So these are just our properties for arithmetic with matrices. And they're just like the properties for arithmetic with numbers. The only thing that we have to be careful with is here we're talking about the zero matrix, not the number 0. And here we're talking about multiplying a matrix by a number. So questions on our properties? All right, let's look at an example using properties. We can solve matrix equations. So let's say we have the equation. We know that we want to solve the matrix equation A minus 2x equals B. And we know that A equals the matrix 2, negative 1, 4, 3. And B equals minus 3, minus 6, 5, 1. So we have this matrix minus 2 times some other matrix. We don't know what this matrix is, has to equal B. Our answer here, X, is a matrix. Well, we can just manipulate this equation just like we do any other equation. We can work with it, we can move things around. So I'm going to add 2x to both sides. So I get A equals 2x plus B. And I'm going to subtract B. And I get 2x equals A minus B. Divide by 2. And x equals, and I'm going to write this as 1/2 times A minus B. Well, A is this matrix and B is this matrix. So x is going to be 1/2 times 2 minus negative 3 is 5. Negative 1 minus negative 6 is 5. 4 minus 5 is negative 1. 4 minus 5 is negative 1. And 3 minus 1 is 2. So my answer, x, would be, now I'm going to multiply each of these by 1/2. X would be the matrix 5 halves. 5 halves. Minus 1/2 and 1. So I solve a matrix equation just like I solve an equation with a regular x and regular numbers. Questions on that example? There's definitely a lot more to write when we do stuff with matrices. All right, we good? All right. The last thing we're going to talk about today is matrix multiplication. Matrix multiplication is a little more tricky than addition and subtraction and multiplying by a number. All right, so for matrix multiplication, we have A. The order of A is m by n. B has to be n by p. The number of columns in the first matrix has to equal the number of rows in the second matrix. If these aren't equal, then we cannot multiply the matrices. So A times B, and I'm going to write m times m by n. This is n by p. These have to be equal, and m by p is the order of A times B. So in order to multiply two matrices, these two numbers have to be equal. The number of columns in A has to equal the number of rows in B, and the order of the new matrix is m by p. And the way we think of multiplication of matrices is we multiply the elements in the rows of A by the elements in the columns of B and add. And I'm going to do a few examples. It's less complicated than it seems, but this is how we think of it. I think of it as multiplying the rows by the columns. So we're multiplying the rows of the first matrix by the columns of the second matrix. All right, questions on this part? So let's do an example. We want to do -1, 0, 6, 2. And we're going to multiply by 5, -2, 7, 1, 0, 3. So this is 2 by 2, and this is 2 by 3. So these are equal, so we can multiply. Our answer is going to be a 2 by 3 matrix. All right, so let's go through the process. So my first element is going to be the first row of the first matrix times the first column of the second matrix. So I'm going to multiply -1 times 5 plus 0 times 1. The first row times the first column. The first row times the second column. So first row, second column is going to be minus 1 times minus 2 plus first row, second column, 0 times 0. First row, third column, multiplying the first row here by the third column here. Negative 1 times 7 plus 0 times 3. So first row, first column, I multiplied the first row of the first matrix by the first column of the second matrix. First row, second column, first row times the second column. First row, third column, first row times the third column. Now for my second row. Second row times the first column. 6 times 5 plus 2 times 1. Second row, second column, 6 times negative 2 plus 2 times 0. Second row, second column. Second row, third column, 6 times 7 plus 2 times 3. And then I add these up to get my result. And this comes out to be negative 5, 2. This comes out to be negative 7. This is 32. 6 times 5 is 30 plus 2 is 32. This one comes out to be negative 12. And this one comes out to be 48. So when I multiply matrices, I multiply the row by the column. First row, first column goes here. First row, second column here. First row, third column here. Second row, first column here. Second row, second column. Second row, third column goes here. And I add those elements up, and my new matrix is 2 rows, 3 columns. So let me do another example. I'll do a 2 by 2 multiplied by a 2 by 2. Any questions on what I did here? All right, so let's look at a 2 by 2, my 2 by 2. I have 2, negative 5, 9, 7. And we're going to multiply by 3, negative 1, 3, and 6. So this is 2 by 2 and 2 by 2. These are equal. So my answer is going to be 2 by 2. So first row, first column, 2 times 3 is, I'll write it all out, 2 times 3 plus negative 5 times 3. First row, first column. First row, second column, 2 times negative 1 plus negative 5 times 6. I'm going to move this out a little bit. First row, second row, first column. So we're in the second row, first column. Second row, first column. 9 times 3 plus 7 times 3. Second row, second column. 9 times negative 1 plus 7 times 6. And I add these up, and I end up with -9, -32, 48, and 33. So I'm just doing this arithmetic and adding, and I get these numbers. First row, first column goes here. First row, second column here. Second row, first column here. Second row, second column here. Questions on that? So again, the way that we think about this, the way I think about it is I'm multiplying the rows by the columns. My first row, first column, first row, second column, second row, first column, second row, second column. Multiply the elements and then add. You get the elements in my new matrix. So again, 3 by 3, if we do a 3 by 3 or bigger, we'll use a calculator. Anything that's smaller than a 3 by 3, we should be able to do by hand. I know it's tedious. There's a little bit of arithmetic involved. It's not difficult. It just takes a little bit of work. One thing to remember about matrix multiplication, and this one is important. A times B does not equal B times A. With matrix multiplication, the order matters. So when we're doing addition, subtraction, everything's the same as normal arithmetic, but we can't switch the order when we multiply. All right, questions? We'll spend a little more time with multiplication on Thursday, and we'll do a calculator review, how to do some of this stuff in our calculator, how to put these in our calculator. All right, homework. Yes, it's 569. All right, there you go.